Tsunamis, nature's titanic waves. The Mediterranean, famous for its calm blue waters and beautiful coasts. But beneath this beauty hides a deadly secret. Scientists now warn, the same forces that destroyed ancient civilizations could one day trigger a devastating tsunami. And all eyes are on one island, Santorini. Welcome back, everyone. Here today, we want to explore the enigma of the Santorini fault system. But first, let's take a moment to appreciate your support. If you're new here, join us on our journey through Earth's mysteries. Let's dive right in. Santorini is not just a tourist paradise known for its whitewashed houses and stunning sunsets. It's also the remnant of a supervolcano that once stood tall as one of the largest on Earth. Around 1600 BCE, a cataclysmic eruption occurred on the island, formerly known as Thera. This eruption wiped out parts of the Minoan civilization, leaving behind a legacy of ash and destruction. The explosive force was so immense that it triggered massive tsunami waves that roared across the Aegean Sea. These waves didn't just stay confined to the waters surrounding Santorini. They traveled as far as the coasts of Egypt, Syria, and Anatolia, leaving devastation in their wake. Fast forward to today, and Santorini still shakes with the rumblings of the giant that slumbers beneath it. This raises a crucial: could this slumbering giant stir again and unleash more devastating tsunamis? To answer this question, we must delve into the heart of the matter, examining the recent findings from a 4-year study conducted by experts at the University of Athens. The Santorini fault system. Santorini sits atop a complex network of faults, fractures in the Earth's crust that can shift and slide, causing tremors. The Santorini fault system comprises several major faults, each with its own unique characteristics and behavior. The main ones include the Archames Fault, the Western and Eastern Faliro Faults, the Akrotiri Fault, and the Southern and Northern Sparta Faults. Each of these faults plays a part in the seismic activity of the region. However, understanding their individual roles and how they interact is crucial to predicting potential large-scale events. What are the signs that a big one is coming? Faults typically exhibit certain behaviors before a major slip occurs. Scientists closely monitor various parameters such as the frequency, timing, and strength of earthquakes, as well as changes in the local geology. By studying these signs, researchers can build a picture of the fault's behavior and assess the risk of a significant event. The enigma of slow slippage. In contrast to traditional earthquake behavior, slow slip events occur gradually over weeks to months without the sudden release of energy that characterizes an earthquake. These events are challenging to detect and were only discovered in the late 20th century. Their significance in the overall seismic activity of the region remains a topic of ongoing research. Decoding the earthquake puzzle. Now let's get back to our exploration of Santorini's seismic secrets. Recent studies of the Santorini fault system have uncovered some intriguing findings. A team led by geologist Kostas Papadopoulos used a variety of techniques, including the analysis of historical earthquake records, geological surveys, and computer modeling. Their aim: to piece together the history of the fault system and understand its behavior. What they found was both fascinating and concerning. According to their research, the Santorini fault system consists of multiple segments, each with its own slip rate, which is the speed at which the rocks on either side of the fault move past each other. The study revealed that the central part of the fault system, which runs along the island's southern coast, has a high slip rate, suggesting that this area is more active and prone to earthquakes. The western and eastern segments of the fault system, however, appear to be locked, meaning that the rocks are not moving relative to each other. Locked faults can store up energy until suddenly released, potentially leading to larger earthquakes. One of the most significant findings of the study was the evidence of slow slip events along the Santorini fault system. Slow slip events are characterized by gradual movement along the fault, releasing energy slowly and steadily rather than in a sudden lurch. While these events may not produce large earthquakes, They are still geologically significant and can contribute to the overall seismic hazard of the region. These findings add to the complexity of the Santorini fault system, highlighting the need for more research and monitoring. The central segment's high slip rate indicates a more active and potentially more hazardous area, while the locked segments and the occurrence of slow slip events add layers of complexity to the region's seismic behavior. Could a tsunami strike today? Given the history of Santorini and the recent findings regarding its fault system, the question arises, could a tsunami strike today? The short answer is yes. The longer, more nuanced answer involves considering several factors. First, let's address the elephant in the room, the Santorini caldera. The caldera formed by the massive eruption of 1600 BCE. Is it still active? The simple answer is yes. The more nuanced answer is that while there's no immediate danger of another large eruption, Santorini is considered a potentially active volcano. Signs like increased seismic activity, changes in the shape of the caldera, and unusual hydrothermal activity could signal an impending eruption. Such an eruption, whether large or small, could potentially generate a tsunami. But what about the fault system? The study revealed complexities, including locked segments and slow slip events. These features don't directly translate to tsunami risk. However, they do indicate a seismically active region where a large earthquake is possible. Large earthquakes in the Mediterranean, unlike their counterparts in the Pacific, have the potential to generate significant tsunamis within minutes. The Mediterranean's smaller size and enclosed nature mean that the waves generated by an earthquake or volcanic eruption can reach coastal areas very quickly, often before any significant warning can be given. Cities like Athens, Istanbul, Alexandria, and Naples are within this high-risk zone. Unlike the Pacific, where major quakes and tsunamis occur more frequently and are sometimes predictable, the Mediterranean's history of surprise disasters is long and troubling. For example, in 365 CE, a massive quake near Crete sent a tsunami that devastated Alexandria in Egypt and reached as far as Italy. Predicting the next wave. So, how do scientists predict when the next wave might strike? The answer lies in continuous monitoring, analysis, and preparation. Researchers are employing advanced tools such as satellite monitoring of the Earth's surface, seafloor sensors that detect changes in water pressure, and GPS stations that track even the smallest ground movements. These technologies are not just passive monitoring tools. They provide an early warning system, allowing scientists to detect any unusual activity, whether it's a sudden rise in seismic activity, changes in the caldera, or shifts in the fault lines. This real-time data collection is vital because it allows for rapid response and analysis. Any significant event can be immediately flagged and investigated, giving authorities and residents precious time to prepare. However, it's important to remember that while we can monitor and analyze, we cannot predict natural disasters with absolute certainty. The Mediterranean's history is filled with seismic surprises, underlining the need for constant vigilance and preparedness. A legacy of disaster. Lessons learned. As we conclude our exploration of Santorini's seismic secrets, let's take a moment to reflect on the lessons of the past. The island's history is rich, but not without tragedy. The massive eruption of 1600 BCE and the subsequent tsunamis serve as a stark reminder of the power of nature. Yet, this power is not something to be feared, but understood. Through understanding the science behind these events, we can better prepare for the future. The recent study of the Santorini fault system is a testament to this. By analyzing the fault's behavior, scientists have gained insight into the island's seismic activity and the potential for future events. This knowledge is not just academic. It's a tool for building resilience. As we continue to explore the mysteries of our planet, let's remember that every discovery brings us one step closer to preparedness. From monitoring the smallest tremors to analyzing the chemistry of volcanic gases, each endeavor contributes to the grand tapestry of knowledge. And when we unravel the threads of this tapestry, we find not just understanding, but also solutions. The question isn't if a Mediterranean tsunami will occur, but when. It's a matter of time, not if. With every passing year, we refine our monitoring systems, improve our predictive models, and strengthen our early warning infrastructure. So the next time you stand by the Mediterranean, gazing at its tranquil waters, remember the giant beneath them. Remember the echoes of the past and the promise of the future. The future lies in our understanding and preparedness, ensuring that we are not caught off guard, but ready to face whatever the Mediterranean may send our way. And thank you for joining us on this journey of discovery. If you enjoyed this exploration of Santorini's secrets, don't forget to show your support. Your engagement fuels our passion for uncovering more of Earth's hidden mysteries. Until next time, keep exploring and stay curious.